Alright, welcome to a video on exercise 7I, that's page 212, and number 9 and 10. I'm glad these two questions were asked about because 9 and 10 are exam style questions, and they definitely are. I very often see this type of problem on the IB exams. It's very common to ask it. Very important to know how to find the equation of a tangent line. So let's look at number 9. The function f of x equals x times e to the x has a horizontal tangent line at x equals k. Find k. All right. This is the main clue. Horizontal tangent line. Horizontal means a line that is left to right, right? It has no slope. It is just a flat line like this, like I'm moving the cursor. So a horizontal line has no slope. That's where you would begin this problem. No slope. So we're looking for somewhere on this curve, this function that has no slope. Where is there no slope? So to find the slope, as you know, the derivative gets us the slope. So let's take a look how to do it. Here's our function. Here's the derivative of that function. Because if we can find the derivative, we know what the slope is. So derivative. How did they come up with this? I see this plus this. Oh, two things multiplied plus two things multiplied must be the product rule. The product rule is what you use when you see a multiplication like this going on, right? We have one function, x, times another function, e to the x. And there you need to apply the product rule to factor that, to differentiate that. So here we go. Product rule tells us you do the first function times the derivative of the second. So here's the first, and the derivative of e to the x is just e to the x. Then you add second function times the derivative of the first. Second function times the derivative of the first. Derivative of x is just 1. So there is the derivative of that. That can be simplified into this. I think that's another key step in this problem, because when you have this, you can't solve that. But this can be solved. So let me show you what I mean. So first of all, horizontal tangent means the derivative is 0, right? The slope is 0. The slope is 0. The slope is 0. All right, here's our derivative, and we're saying when is that slope equal to 0? When is it 0? When is that slope 0? All right, if we had put 0 equal to this over here equals 0, we could not solve that. But this, since it is in factored form, we can solve it because we have something times something equals 0. So that means we can take each factor and set them equal to 0. So e to the k equals 0, and k plus 1 equals 0. Oh, wait a minute, where did the k come from? Okay, because, let's see, go back here. We know the horizontal tangent occurs at x equals k, all right? So that means into this function, we put in an x value of k. So we replace that with k and that with k. So we have k there, k there. So this equals 0 or this equals 0. This one does not exist. If you graph this exponential function, every exponential function, watch my cursor, has this shape. Whoa, all right, starts here. Whoa, all right, starts here. Whoa, and it never touches the x-axis. There's an asymptote there. It just goes up like that and never touches. So it never equals 0. All right, the y value is never 0. There's an asymptote there. So that one has no solutions, but this one does. K equals -1. So there is our value of k. Let's look at number 10. Number 10, write the equations for the tangent lines to the graph of this that are parallel to this. All right, if there are tangent lines parallel to this, well, first we need to figure out what is the slope of this line. This is a line. What's the slope? Because any parallel lines will have the same slope. So once we know this slope, we'll know the slopes of the parallel lines. All right, so here's our function. Here's the derivative. Anytime we start talking about slopes, we should find the derivative. So this is something divided by something, a function over a function. Oh, it's a quotient of functions. That's amazing. All right, when we have a quotient of functions, we should use the quotient rule, which tells us bottom function times the derivative of the top, the derivative of this is 1, minus top function times the derivative of the bottom, which is also 1, divided by the bottom function squared. All right, so we have that. That simplifies to this, which turns into this. All right, it's good to simplify it. Now we know that's the derivative function. That's what, oh, let's go back. This is going to tell us the slope everywhere on this graph. And as you change the x values, you're going to get different slopes. All right, so now we know Here's that equation of the line that was given to us up here. We're going to rearrange it to this so that we can get the slope. And once I've rearranged it, I see the slope is -1/2. There's the slope. So now we're looking for lines that are parallel to this one. If they're parallel to this one, they have the same slope. And they have to be tangent to here. So they have this slope. Tangent to here, this slope. Oh, well, we have the slope, the derivative is the slope. So if we say, when is this slope equal to this? -1/2, all right? So that's what we're going to do. When is this slope, which is the derivative, equal to -1/2? When does this give us this slope? All right, solve that, cross multiply, take the square root of both sides. Square root of 4 is plus or minus 2, and you get two values for x. So at those 2 points exactly on this graph, there will be tangent lines that are parallel to this one because they will have a slope of that. So first of all, we need f of 3. We need to know what is that point. We know x value is 3, but what's the y value? So we plug it in. Oh, y value is 2. Then we take x is -1. Put it in here in the original function. Plug it in. 0. Oh, okay. X value -1. Y value 0. From this one, we can write the equation, right? Y minus the y value equals slope times x minus the x value. This is how we come up with the equation, right? And here's the equation for that one. So these haven't even been rearranged. It's just the two equations of the two lines that are parallel. Great. Hope that makes sense. If it doesn't, got to review your derivatives, slopes, equations of tangent lines, and so on. All the best to you. Good luck.